Hello everyone and welcome back to Kickstart Your Cybersecurity Career Training, Module 2. So in this module, we'll be covering the incident response process. We'll be covering from the point of before an incident happens, before an attack, a cybersecurity attack happens, until we understand fully what's happening in our system, how the attacker came here, and what's exactly happening inside the machine. We'll be going through the preparation phase, the log analysis, and then the live forensics analysis in the machine itself, and we'll see all the steps in this process. So first, we need to understand what's an incident, what's actually called an incident. Incident implies harm or attempt to imply harm. It might also mean a law has been broken. So it could be a cybersecurity attack that implies harm or attempt to imply harm. It could be a disaster, normal natural disaster like flooding or some tsunami or earthquake. All of these are considered incidents. But what we'll be talking about here today is the cybersecurity attacks, as you might have imagined. And we'll be talking about what are the steps that we need to do to make sure that we handle an incident correctly. So the incident response process is basically these 4 steps. Preparation, which happens before an incident happens. By the way, this process has been created by NIST. I think 802 or something like that, or 807, I don't remember, that has the full incident response plan. You can check their documentation about their incident response plan. Anyway, so this is the incident response process. First, it starts with the preparation, and this phase is before an incident happens. The incident handling team, if you're working incident response team, this team is not relaxing and smoking until there's an incident and then they start work. The time before an incident, they have to prepare everything for this incident. And the preparation comes with the process, what exactly they will do when there's an attack, when there's a ransomware attack, how they will react fast, who should do what, and what's exactly the steps that you have to follow to be able to handle the incident. And that works for different threat scenarios. The preparation needs also about the communication. How you communicate with the team, with the stakeholders, with the external teams, how you will deal with other teams that can be involved. Let's say how you will deal with backups, for example. Let's say there is an incident related to Oracle database, and the Oracle database manager, or the person who managed this database, the only person who managed this database is actually on holiday. Who's the backup? Who can deal with this? Who can help you with that? Who is in the team dealing with communicating with the stakeholders? Who is dealing with the incident itself? What you will do if the incident is really big and you need additional people to join? So all of these are very important. Who is the external teams that you can rely on to help you with the incident, and as well communicating what's happening through the incident? This is an important process. The people. Then comes the technology, the software, the hardware. There is what tools you need. You need a software like Incase, or you need other investigation tools like other tools like FTK, whatever. So what are the tools that you actually need? Maybe cloud tools that helps you with forensics, with memory analysis, with sandboxes if you want to do some analysis on malware. Whatever the tools that you need, whatever the technology. As well, the hard disk, the hardware. You might need hard disks, for example, to collect the memory dumps, to collect the disk dumps, the full disk image. And you need, let's say, 2 terabytes hard disk that is wiped right now to go and collect that. And you discover that you don't have a hard disk that is empty that you can use for collecting the incident information, or is not fully wiped, or you need to wait and you need to go here and do that. You need to prepare all your tools ahead before an actual attack happens. You don't need to discover you have a problem at the time of the incident. As well, you need your team to be trained on the process you have built through maybe drills, and you can do like assessments and different things. We call them drills, where you have like an attack that had happened, and get the team to follow the process and get them to practice this process. As well, trainings on incident response. The training that you're listening to right now is a training for incident response, for malware analysis, for people who are building their career in cybersecurity, as well as people who are working in incident response, people who are coming from SOC to work in incident response. You need trainings for the team to be prepared for an incident when it happens. You don't need to discover that you are missing critical skills in your team after the incident happens, and then you have to rely on a company from outside to do the incident response. So this is the preparation phase. Other parts of preparation is to make sure that you don't have lots of clutter, you don't have lots of internet communication that you don't know what is that, protocols that are being used in your network that you don't know anything about, ports are being open with no need, stuff like that. You need to make sure that you can easily spot there is an attack, you easily spot something suspicious. You don't need old users being hanging there and nobody's using them, or you don't need lots of clutter. You just need to have your systems are clean, processes are ready, team are ready, all the teams are being informed who will communicate with them and what they exactly will do. You have the technology in place, you have the team with the right skills, the hands-on skills that they can move on when there's an incident and act fast. This is the preparation phase, and that takes the longer time. After the preparation phase, when an incident happens, first you will need to detect that incident. Most of the incidents are being detected not on the machine itself. That happens sometimes, but mostly either through log analysis. Something suspicious happens in the log, or in the network phase. The network part, there's a suspicious domain, there's a suspicious network activity, there's something suspicious happening up there, or a third-party reports that calls and say, oh, we have seen that your systems are being compromised by this malware or by this attack. This is all the information you need to respond, and then you kick off a response process. Now, with also some of the detection tools on the endpoint, it becomes easier to detect attacks on the endpoint, like with endpoint detection response, or the host IDS alerts, or whatever your tools for investigation. We'll talk about that later. But in the past, mostly it was about network detection. And now with the endpoint detection response, it become more common to detect attacks or suspicious activities through the logs that coming from the endpoints. As well, apart from all the ways to detect something suspicious, which mostly what is handled by the SOC, there is also another way to detect attacks is through threat hunting or any internal investigation. And threat hunting is expecting that you are already compromised. That's the hypothesis. You create a hypothesis that you have been already compromised, and the attacker is using these techniques to get through your systems. How you can detect these attacks, how you can detect if this hypothesis is actually true, go and investigate further and find these patterns of suspicious activities that you imagine the attacker is following, and try to investigate further and stop the attack if there is an attack. If you discover that there's actually no attack and there's no problem happening on your systems, then how you can be alert to this hypothesis every time. So to make it more specific, threat hunting, you can say, I think that I have been compromised and the attacker used a malicious document with a macro sent through spear phishing, and this macro code executes PowerShell commands, and he's moving laterally inside the organization by running his PowerShell commands that installs different malware, and this malware is communicating with peer-to-peer communication, and all of this is happening, right? You can now do an investigation, assuming that all of this is being true, assuming that there is malicious peer-to-peer communication, these malicious documents have been opened and the malicious macros have been executed, PowerShell commands have been executed with users who are not IT users, who are not IT support or not system accounts. You can start investigating all of that. You expect maybe a Word.exe, a Microsoft Word or Microsoft Excel, or one of these apps actually executed PowerShell commands. That is something very, very suspicious. If the Microsoft Word has created another process called PowerShell.exe and executed a command, this is something that's not usual. So you might investigate further and see why that's happening and how that happened and what PowerShell command is doing, and you start investigating further. If your hypothesis wasn't correct, there's no attack that's happened like that, you are not compromised, then how you can create dashboards and creating alerts and creating different ways to detect if this actually happened in the future. So if there's no peer-to-peer communication, can you create a dashboard or an alert that can detect one machine communicating to so many machines, or multiple machines connecting to each other in different or unknown protocols, and so on. And this is basically the threat hunting, and that can lead to detection of different attacks. Implementing new technologies or new alerts can detect some attacks. A case, let's say Asus, they had a malware in their tools. They had a tool that's being shipped with all of their Asus laptops. They're being shipped to so many, to millions of users. And this tool that's in all of their laptops was compromised, and there is a malware being installed with this tool in all the laptops that have been spreading to all the Asus customers. This attack has been discovered by running a code check. They have implemented a new security technology to check to verify the source code and make sure that there is nothing malicious being deployed on their laptops, on the laptops that they ship. And they discovered that running this tool, they discovered that there was a malware actually being deployed in all of their laptops, and they have discovered this attack and discovered that there were over 1 million laptops have been compromised because of their tool. So it might be implementing new technologies to discover any malicious activities or discover that you are being compromised. So this is the detection phase. Once you detect something, you need to investigate further. And the best way to investigate further, the first way, is through log analysis. So what is log analysis? Log analysis was built first as a way, some applications or many applications, when they run, they might have some errors, might have some bugs, and the developers used to make these applications print some messages along the way when they are running to give an indication where the error has been in the middle of the application, and what this error was and what had happened with this error, and so on. And all of this information is being written to a file, not to appear to the user, because the user is not related to these errors, but they are written in a file, and this file being sent when there's an error happens. And the developers look at this log file and see, okay, this event had happened, and then this error has been appeared, and then the program has crashed. So this is the problem. This is where we need to go and investigate. So that was the first reason for creating logs. Then later on, it has been used for security reasons. So for a firewall logs, we can see all the people has been trying to connect to the internet. What's the accepted, what has been allowed, what has been denied, who is trying to scan our systems. If one IP is trying to look through all our ports, look through all the ports in our in the whole let's say from 0 to 65,000, if an app is trying to scan all these ports and trying to hit any of ports of us and the firewall is blocking all of them, then we can see that there is a port scan has been happening through this IP, and this is something suspicious. Did that IP do something else on our system? We can see what are the connections that have been allowed, what had happened through them. This is maybe the firewall logs, but then we can see also other logs like the web application log, and we can see all the connections that happen through our website. What's exactly the requests, and did we see any requests that include some malicious commands or some SQL injection type of patterns or XSS type of patterns? If you don't know what I'm talking about, they are all web attacks, known web attacks. To learn more about web attacks, I recommend you to check OWASP, OWASP, top 10. The OWASP top 10 are basically the top 10 attacks known for web attacks. Anyway, logs helps us to identify if there's anything suspicious that been happened, and as well can help us if we correlate different information. We can help us understand fully the attack that has been happened, and understand also the scope of this attack, what machines have been compromised, what accounts have been compromised, and so on. With log analysis, we have inside an organization, we have so many different types of logs. We have logs related to authentication, which helps us detect brute forcing for accounts, trying to guess the passwords. So we can see lots of failed requests, and some has been succeeded. We can detect as well other attacks. We can detect some accounts doing things that should not be happening. One user is logging in with Remote Desktop into so many of his colleagues' laptops. Why he's doing that? That's not a normal behavior. So you can see the user's behavior and the accounts associated with them and how they behave and what is suspicious being happening, like off-hours type of activities, night activities, weekend activities for no reasons, logging into different machines, and so on. So with this, we can see them through our Active Directory, which is the domain controller we talked about in the previous module. So it does have logs, and these logs can tell us a lot about how these accounts are being used. We have as well the LDAP, which is also used for logging. We have database logs for their authentication and so on. We have the VPN, if there's a VPN and people working from home or even in the office, and there's VPN network, you can see what this network is exactly, what's happening inside this network, and who's connecting to it, and if there's any connection from outside the normal IPs or from far country or something like that. So that's for authentication and user rules and privilege and so on. There's also on the host, on the laptops in themselves, that there's a malware running, or there's a malicious communications happening, or malicious activities, or a way to, or some tools are being used to harvest passwords from these machines, or domain accounts, and so on. You have the antivirus logs. All the antiviruses have logs if it's being enabled, as well as the host intrusion prevention systems, which is unknown tools as well. There's more recent tools called EDRs, or endpoint detection response, and these tools also give you so much of information about what's happening on the system. They are kind of like antiviruses, but created to produce so much of logs to give the security team more control and more ability to understand what's happening inside these systems. Apart from endpoints, operating system logs can also be a really good source of information. Windows event logs, this basically saves so many events that have been happening on the system. Additional to them, Sysmon logs, which is a Microsoft tool as well. Sysmon or System Monitor is also a tool that aggregates lots of different logs from Windows events and make meanings of them and create logs that are specialized for security response. And these logs can include files have been created, files have been deleted, registry activities, process have been created, process activities, as well as network activities, domains have been accessed. So many of information, so much of information you can find there. There is PowerShell logs. You can see what's happening through PowerShell, what commands have been executed, and so on. There's so much of information you can find on the host, and so many different logs you can enable. About the logs, you can also look above the host. You can also look at the network security from firewall, from IDS, IPS. Intrusion detection system that detects if there's that has patterns, kind of like antivirus signatures, but through the network, and it detects if there's suspicious activity has been happening there, as well as vulnerability scanners, which is not really logs, but it can tell you if the systems have vulnerable applications have been updated, and there is vulnerabilities or weaknesses that might be exploited through internet, and these vulnerabilities can, or these exploits can take over the machine, or take control of the machine, can execute some commands on the system, or can do whatever the damage the attacker wants to do something that's not supposed to happen. Vulnerability scanners allow you to scan for weaknesses inside your system, and systems haven't been updated to the latest update, and so on. That can be also a source of information to know if you are vulnerable to known attacks or known vulnerabilities, known exploits. Exploits are tools that used to exploit a vulnerability or take or abuse a weakness inside an application, a bug inside the application, to do something the attacker not supposed to do, or the user is not supposed to do. Network activities can be DNS logs. DNS logs can tell you about all the domains that have been accessed through your users' browsers, your employees' browsers. Not only their browsers, but also any applications running on their system. And it's good to detect any callback to the attacker. If any malware is trying to connect back to the attacker, you can discover the communication link, and basically find all the compromised accounts that's trying to compromise systems that tries to connect to that attacker. Maybe this is a malicious website like malware.ru, for example, with big respect to Russians, but malware.ru or malware.cc, for example, and this domain is being used by 10 machines in your system, and there's a malware is being communicating to them. So DNS logs helps you to identify that. With all of these logs, the problem comes is that there's so much of information, so much not only of logs, but also alerts. Your tools that tries to detect something suspicious in them already producing too many logs for your team to analyze. There are tools that helps to manage and correlate this information and tells you if there's something suspicious happening. Tools like SIEM, security and event management systems, security information and event management, and these tools are basically correlate all of these logs and find suspicious patterns. But because there are so many of them, you might only be able, or your SOC team might be able to only see 50% of them. That is the maximum they can reach, and there's another 50% of alerts and information you haven't actually spotted. You haven't even logged at. And this could be, some of them are the malicious activities you are searching for, and the attacker is already going inside your systems silently without being detected because you couldn't see all the logs. And because of that, you will need threat intelligence to prioritize this information. So threat intelligence are basically information about different attacks that happened on other companies, on other systems, in other countries. And these attacks are hot attacks. These actors are still targeting your system. They are targeting systems like you, and they might be already compromised your organization, or trying to compromise it as soon as possible. So this threat information helps you to identify any malware, known malware, knowing malicious domains, knowing malicious IPs, knowing indicators of being compromised, something called, they call it IOCs, or indicators of compromise. And these IOCs or indicators of compromise can tell you if you have been compromised or not. As well, it can help you prioritize your alerts, prioritize all these events in your logs, and tells you what the thing that you have to look at first and what you have to respond to first, so you're able to protect your organization as much as you can. So there's so much about logs we can talk about here, but what I want to say is, what I want to focus on now is what are the things that you have to look for through the different logs. There's so many of them, so you might need to understand what's exactly everyone can give to you. Sorry. So this, there's DNS logs, and this is DNS logs are good to detect suspicious domain activities. Domain activities like suspicious websites, as we say, malware.cc, or a domain that, or let's say 100 domains that are not existent, and there's one machine is trying to connect to these 100 domains. So probably it is generating domains and trying to find a domain that the malware, that the attacker has actually bought. There is something called the random domain generator, or DGE, and is a known technique for malware. Rather than they only connect to one website, which can be blocked, they generate domain every day. They generate 10 domains or 100 domains, and one of them the attacker actually buys. So you cannot block them through firewall, because every day you have to block new 100 domains to make sure that it doesn't communicate to the attacker. As it is very hard to block, it is very easy to detect through your DNS logs, because you can see 100 unknown random domains. They look very random. 100 domains the one machine has tried to connect to, and all this 100, there's no DNS, there is no DNS records for them. These domains don't exist, these websites don't exist actually on the internet. So that's a good indication there is a malware with domain generation algorithm is running there with generating random domains. So this is for DNS logs. You have Apache logs, which can help to detect web attacks. As we said, SQL injection, XSS, don't know why SSL is here, but anyway, it detects XSS and different types of web attacks. Detect if there is commands have been sent through website parameters, for example, and like remote command injection, and so many different things. So this helps you with detecting web attacks. Any attacker has compromised your website and used your website to get into your network and actually spread through your network or collect valuable information. You can also see through the email logs to detect if there is spear phishing attacks. We talked about the spear phishing in the previous module, and it is very good to see if there is one email has been sent to so many people, including a document, what the document has been sent, what's exactly the header of this email. Maybe it has a fake name or a fake email that looks like it is from that let's say email support@google.com, but it's actually not from support@google.com. It's from something else. You can detect all of that through your email logs, as well as you can detect if there's one malicious email has been sent to different accounts. Then one of these accounts started sending the exact same email to 10 other employees inside the organization, and you see this pattern over and over again. That's something you can see through email logs, and can tell you that there has been spear phishing that is happening on this organization, and then they were able to compromise some of the accounts, and through these accounts they started sending the same spear phishing emails to other people inside the organization, in personalizing one of the employees inside the organization to add legitimacy to these emails. So email log can help you detect that. Event logs is really helpful in detecting account compromise or lateral move activities, as well as can detect so many different things. Most of the things you would see on the host base can be detected through Windows event logs or sysmon logs. As we said, deleted files, deleted registry keys, modified registry keys, domains have been accessed, processes have been created, and so on. PowerShell logs. PowerShell is a tool or a language actually that's being used by IT administrators to do different administration things to automate administration on Windows, as well as it can be used by attackers to run malicious to do some malicious activities on the system, downloading different malware, executing this malware, deleting files, communicating to other machines, stealing information, and so on. So it gives more powerful access. It's a powerful access to Windows, and Windows functionality can be used by the IT administrators as well as the attackers. It's being used. It's very common in fileless attacks and lateral movements, moving from one machine to another inside the organization. And PowerShell has its own logs. You can enable the logs and see what exactly the commands have been executed and when, which is really good to detect suspicious activities. You have as well the endpoint detection response logs. We talked about them. And as well, you have the firewall logs and so on. With endpoint detection response logs, you can detect processes have created like a chain of connections between different processes. So Chrome browser has executed PowerShell, or Word.exe has executed PowerShell, or different things like that that look suspicious, or JavaScript run through an app like WScript, through an application called WScript that executes JavaScript code, and then it executed another that opened CMD and then executed WhoAmI, for example. And this chain of connections looks very suspicious. Endpoint detection response helps you to detect that. So there are different things inside your logs that you can use to detect. As well, as we said, logs can all be gathered from all these different systems, from all these different points, into one tool called Security Information Event Management. And this tool helps you correlate this information, so you can see that this one IP has accessed this machine, has accessed this account, has also tried to scan different ports from the firewall logs. This machine that he is accessing has connected to this domain that looks suspicious, and so on. So you can correlate this information and create a story, a full story out of all of them. There are so many different tools, different security information event management tools. There is the ELK, which is an open source one. It includes Elasticsearch. Elasticsearch is basically a tool that you send JSON files, and it helps indexing them and easily search inside of them. Elasticsearch can work with so much of data, so like gigabytes or terabytes of data, and they are all easily searchable and accessible, which what makes Elasticsearch a very known search language and search tool to use to correlate lots of information and dealing with logs. Elasticsearch is the indexing and correlation. Logstash is the tool where it goes and collects all of these logs, ingest them, convert them into a readable JSON, and push them to Elasticsearch. This is the tool that works in the back end, that collects all of this information for you, organize them, and save them in Elasticsearch, so they can be searchable. Elasticsearch is enough to use to just queries through its API. It will return a JSON response to you. You send to Elasticsearch a JSON request with some query, and it will come back in a JSON format. If you don't know what's JSON format, it's just a format of representing data. If you saw XML, it's something similar, but it is easier to read. So all of these tools are good, but they are not very user-friendly. Kibana is the UI for all of this that makes it very user-friendly. You can just do like a query in a search bar, see everything in a graph, and visualize different things. And it's just a UI that is very rich, and it can help you finding information inside all of that. This is one tool. Another tool which is very known is called Splunk. Splunk is not free. It has a free trial. You can install. It has also free access. You can install the free trial and then go to the settings and change the settings to make it just free. I will show a demo of Splunk soon after this session, and I'll show you how Splunk actually works. So this is ELK and Splunk. They are the most known tools. There are so many others tools that are not free, like Logarithm. There's also other SIM tools, and they are for enterprise, like premium tools. Beside all of that, there's also other new technologies like network detection response. And these tools are a bit work differently than log analysis. So we said logs has been created as a way for debugging. Then they were used to being ingested in a security management tool, in a security information and event management. And these tools trying to to understand these logs and trying to get some information out of them, some security information. This is what used to be happening. Even with antivirus, it used to create logs, but these logs were related to the antivirus for debugging reasons rather than for ingesting for security reasons. It has been mainly created for security. Then EDRs appeared, which is the endpoint detection response, which were creating logs for security reasons to understand and have more visibility over the endpoints and have more visibility over the systems. What's exactly happening? The logs are being created just for security. That will also happen in the network phase. So there's something called network detection response, which are tools that set some sensors along your network. They don't look at the logs from the firewall, from the DNS, from all of this. They don't look for these logs. They put sensors, and these sensors actually create kind of logs that are made for security reasons. And these logs can include also a sample of BCAPs to be able to investigate deeper into the attack if there's something suspicious. These tools are all connected to an AI system or a machine learning system that tries to understand what's exactly happening and looking for something suspicious. And with these suspicious activities, they store its BCAP, they store it as an alert. So it's a different idea of looking into log analysis. Rather than you look at the logs that are being generated by different apps, mostly not for security reasons, you are actually creating logs that are specifically for security. You put sensors all over your organization, and you see all of this information organized in a good way inside your NDR. So this is basically another technology is being started to roll out recently. So this is one thing. There's also a free, I would say, a free VM or a free ISO machine, free machine to download, or like Linux ISO file. There's a Linux distribution called Security Onion, and this is used for network security monitoring and includes lots of tools. One of them is the ELK that we have described, and so many other tools for log analysis, for network analysis, for BCAP analysis, for replaying BCAPs for analysis reasons. everything you would imagine related to network security is included there. All the free tools, you can download it from Security Onion and install it in your VM or in AWS or wherever you want as well. All of that is good. Log analysis is really great, but so many different things cannot be seen through log analysis, and it needs more in-depth investigation or through PCAP analysis. Like malware today, they are using HTTPS to avoid PCAP analysis. With using HTTP and using HTTPS, these protocols can easily bypass firewalls, so you don't see much happening in the firewall part. In DNS, you can see lots of information, but you can only see the domain. Sometimes you might not even see the domain because there's DNS over HTTPS that's been introduced recently. So you might not see much of activities through your log analysis or through your network analysis or PCAP analysis. You need to investigate the machine deeper. For now, we will take a look at a demo that explains a little bit how the log analysis look like and how we can use log analysis tools like Splunk, for example, to investigate further to find suspicious activities inside a big file of logs, and as well able to data mine, able to connect the information together and find the attack out of this, find when it started, how it started, how the attack looks like, and all the activities, the suspicious activities that happen. We'll take a look at a web attack example. We haven't talked so much about web attacks, so in this demo we'll look at a web attack. It's a Drupal website, and this website has been hacked, and we saw an evidence of a shell that has been dropped inside this Drupal website, and the attacker used it to take control over the server. So we'll investigate the logs further and see how that exactly happened. See you in the demo.